So local climates are called microclimates. This is a local pattern in the climate. And here in the Ozarks, one side of a hill can have a very different climate than the other side of the hill. And I've had it where I got rain at my location, and 1 mile away, my neighbor got nothing at all. So the topography, heat islands, heat domes, many things can affect those types of things. Can be associated with a single tree. Lichen and moss grow on one side but not on the other. So depending upon what you want to view, the globe or a continent or a county or a district, depends upon what you are going to be calling your climate. Now, climate change is always happening. This is not something new. Climate change is a departure from a current average pattern of climate over a period of time. And it is never, it is never exactly the same. Proxy data have been used to infer past climate conditions. Okay, this is fraught with potential for misuse, and a lot of times where you see graphs with straight lines, there is nothing connecting those dots whatsoever. Data about ice ages and interglacial warming show periods of warming and cooling occur in large cycles. Yes, that's true. During the past 100 years, Earth has experienced 2 warming cycles and is now cooling despite extremely slight increases in carbon dioxide. Okay, so what had been forecast in 1990 was that the increase, if we didn't do something to control the carbon dioxide, this heating was just going to continue. Well, the largest polluters, India and China, greatly accelerated theirs, but nevertheless, the Earth is now cooling despite that. So just one more example of why the 38 different models, computer models that they had, bear very little resemblance to reality. Temperature changes are not uniform. The text said might be described as global weirding. Actually, it's more of a political ploy than anything else instead of global warming. So it's something people need to be aware of. It's something that people need to be following. And especially if you're a local farmer, you want to know what's going to be happening and plan accordingly. But nevertheless, it has not been something that is a cause for alarm, nor is it something that you spending a whole bunch of dollars will correct. Every single quote-unquote scientific solution from the 1960s on, where they're talking about sprinkling carbon dust all over the poles to allow them to melt to help warm the planet, because that was one of the cooling cycles. It's just nonsense every single time. So the causes of global climate change, first and foremost, are sunspots. Okay? But it's an interaction of many different factors, and it depends upon where you are. But sunspots, I mean, this is where we get all of our energy from, right? It comes from the sun first, before it's converted by plants into things which we can burn. Complex interact, and in addition to those sunspots, it's also the Earth's tilt, orbital shape, axis wobble, the different gases we have, all sorts of different things. Let's go on then to the Earth's waters. But it's just the final comment about the whole global climate change is that, first of all, it depends upon where on the globe you are, whether something is beneficial to you or not beneficial. I know some people up in Canada would actually like to have a few more degrees of warmth to give them a little longer growing season, and it hasn't affected anyone else either. And the oceans are not rising any more than they ever have been. Earth's waters, chapter 24. The hydrologic cycle is evaporation of water from the ocean, transport by moving air masses, precipitation across the surface, and movement of water back to the ocean, right? That's the cycle that happens. Water is the most abundant chemical compound near the Earth's surface. It covers 70% of the surface. 97% is in the oceans. Only 3% is fresh water. 2/3 of that is in ice caps. Less than 1/3 is available to us. Okay? So that gives you an idea how valuable those ponds and lakes and streams are that we have, and why everyone wants a place on the lake shore. Hydrologic cycle: evaporation of water from the ocean. Water vapor is transported to other locations. Precipitation returns the water to the ocean directly and indirectly. That's the hydrologic cycle. Precipitation is the basic freshwater source. 2/3 returns to the atmosphere. The remaining 1/3, runoff, flows downhill, sometimes taking a lot of stuff with it. Groundwater is absorbed into the surface and can emerge elsewhere as runoffs. Runoff groundwater distribution depends upon the soil type, the dryness, the type of rocks you've got down there, the amount and type of vegetation, steepness, and rate of rainfall. We've had sometimes 2 and 3 inches in a 24-hour period here. There are places where they have 10 inches or more of rain. In the Philippines, for example, 10 inches or more of rain in a single day. Surface water: collectively the waters in streams, ponds, lakes, and reservoirs. This is a watershed. Is the land's area drained by the streams or streams, right? So we've got the White River watershed, and we've got the other ones in our area here. 2 adjacent watersheds separated by the divide, right? Continental divide separates watersheds draining into the opposite sides of the continent. I always thought that the continental divide was, someplace right here in the center, but it's not. It's way over here. Only this side drains this way. Everything over here drains this way. And that's why all of this right here drains down through the Mississippi River. Well, the Missouri, this is the Missouri up in here, and it drains down through here and exits right there into the Gulf of Mexico. Okay, so this is quite an amazing type of distribution system that they have here. Groundwater is underground water saturating open spaces between rocks and soil particles. It percolates downward from the surface. There's 25 times a larger supply in the ground than the surface fresh water. It's often within 100 meters of the surface. So you can dig a spot almost anywhere, and if you go down about 300 feet or more, you're going to hit water someplace, hopefully. It depends upon how it flows, depends upon what the soil composition is. Sand and gravel have a lot of open pores, permeable to water flow. Clay, low porosity, impermeable, and just makes a slick layer up on top. Zone of saturation is collected groundwater from an impermeable layer. Water table is the top boundary of the zone of saturation. Water can move laterally within this zone. An aquifer is a subsurface layer of highly permeable material capable of producing water. An artesian aquifer is confined under pressure from water at higher elevations. And so there you can have an artesian well. And this well is spontaneously just going to come up from there. A lot of springs are like your artesian wells. Fresh water as a resource required for life processes and modern industrial society. Average U.S. usage is 570 liters per person per day. That's okay. Now, nobody drinks that much, right? Only a little bit of that, about 2 or 3 liters, is consumed by a person, sometimes as much as 8. That's about it. Most of it is agricultural, production of electricity, or industrial, right? So you're don't expect to be saying, okay, I've got this much water I get every day. It's not. Most of it goes in these other applications. Most of the supply comes from surface water and depends upon precipitation. 40% comes from groundwater. Okay? And it has to be pumped to the surface. Seawater, 70% of the earth is covered by seawater. Average depth, 3,800 meters. Okay? 30% of the Earth is dry land with an average altitude of 830 meters. Most of the ocean is still unexplored. Oceans and the seas. The ocean, there's 3 principal regions, but it's actually one continuous body. Okay, there's no connection here between South America and Antarctica. There's no connection from the United States across to Russia. Even here, there's a gap there. But nevertheless, it's all one body, but it's divided into 3 primary regions: Atlantic Ocean, the Pacific Ocean, which is the largest, and then the Indian Ocean, which is the smallest. Okay, a sea is a smaller region distinguished by special characteristics such as the Mediterranean, Gulf of Mexico, Caribbean. These are bound by land. So this is the Caribbean right here, and you've got the land masses almost isolating it. This is the Mediterranean. You've got land masses most of the way around it, right? And so on. The nature of seawater. These are all the different materials dissolved in seawater. Chloride, sodium chloride makes up the salt, right? Sulfate, magnesium, calcium, potassium, bicarbonate, and bromine. That makes up 99.89%. And you see the majority of it is just sodium and chloride, right? The mass of the salts dissolved, this is the salinity is determined by this mass right here. It averages 35% with 32 to 36% range. Okay, concentration increases. This is not right. Averages 35% with 32 to, I think that's 3.5%, 3.2 to 3.6. That's the percent salinity, right? Not 35%. 3.5%, 3.2 to 3.6. That's the range of salinity in the ocean. Concentration increased by evaporation and ice formation. It's decreased by heavy precipitation, ice melting, and river flow. And the proportion of these ions are fairly constant. Okay, so anyway, also contains dissolved gases, nitrogen, oxygen, large amount of carbon dioxide, because you've got a lot of plants in the ocean. Most of the plants in the world are in the ocean, the algae and all of that. They need that carbon dioxide in order to generate the oxygen that covers the surface. Mixing time of Earth's seawater, anyway, I would not, there's nothing to back up these numbers. The diffusion can occur and you can calculate some numbers, but you need actual data to back calculate. Okay, 2 types of motion: waves produced by disturbances, movement of water from one place to another. And the simpler, you've got crests, troughs, wavelength, and the wave period is the time between the different waves. Ocean waves from the wind speed, the length of the time that the wind blows, and the fetch, which is the distance the wind blows across the open ocean. So if you have a small pond, you're not going to get very big waves. The bigger the area of water, the higher the fetch, right? Complicated mixture of wavelengths and heights generated. Smaller waves dissipate from friction. The big waves are the one you want to catch with your surfboard and ride on in. Swells carry energy but do not transport water. Individual particles are in motion, so it just goes up and down, but they're not moving. Whitecaps formed when the top of the swell is topped by a strong wind. The shore effects, where you get refraction at the shore surface. Breakers at a depth less than wave height. The surf breaker is a formation zones. When you see the surf, you are talking about these type of breakers. Undertow is possible. Longshore currents are possible. Things to watch out for if you're out there swimming. Ocean currents are streams transporting water over large oceanic distances and are produced by the density and the wind blowing persistent in the same direction. Those are the 2 things that cause the ocean currents to take place. You also have these are the density currents right here, changes in salinity, and then you have the surface currents caused by the winds. And that's it.